Hello everyone, this is Fahad Mirza and I welcome you to my channel. In this video, we are going to have a look at one of the tools which I believe is not only quite interesting but quite promising too. This tool is called as TorchCP. Now you might have a feeling that this is mainly geared towards machine learning engineers or deep learning enthusiasts, but I believe that all of us need to at least understand these sort of toolboxes, frameworks, which are deeply related to bit of foundational work, because if you have been following my channel, you might have noticed that I installed Torch for almost every model I installed locally, and many of the tools which I use require Torch. And this Torch CP is closely related to that. But don't worry, as is the spirit of the channel, I'm going to keep it as simple as possible. You don't have to be a machine learning guru in order to understand this. So what I'm going to do here, I'm going to describe what this TorchCP is in very simple words. We will also be installing it locally, and then we will play around with it a bit because mainly it is geared towards your own specific use case. So let's start. First up, what is Torch? Torch is an open source machine learning library which we use for build and train artificial neural networks or models. Mainly it is used for all the AI tasks. TorchCP is a Python toolbox which has been built on top of Torch. It is specifically designed for conformal prediction. Conformal prediction is a statistical method that provides a level of confidence in the predictions made by a machine learning model. That is what it is. There are two key differences between Torch and TorchCP. Torch focuses on building and training deep learning models, whereas TorchCP focuses on providing conformal prediction methods for deep learning models, enabling more reliable and trustworthy predictions. Now, let's try to get this thing installed on our local system and then we will see how it works. Before that, let me give a huge shout out to Mast Compute who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on very affordable prices, I will drop the link to their website in video's description. I'm also going to give you a coupon code of 50% discount on range of GPUs, which you can find in video's description. So this is my Ubuntu system and this is my GPU card NVIDIA RTX A6000 with 48 GB of VRAM. Let's install Python 3.9 because this tool TorchCP is compatible at the moment with Python 3.9, so that is why I am creating this virtual environment with it. Let's wait for it to get created. And now let's install TorchCP with some of the things which we require for our demo, like transformers and protobuf sentence piece. This is going to take a couple of minutes because it installs a lot of things, so let's wait. And that is done. Let's git clone the repo of TorchCP. It says it's already exists. I think I already used it before, so I'm just going to remove that one just to make a clean install. Let's do this now. Okay, that looks better. Now, before we move forward, there are few of the issues with this GitHub repo which I have spent like 2 hours to make it working. So let me show you that. I'm going to open it in my VS Code and I will show you the changes which I had to make in order to get it working. Okay, so the first change I needed to make was in this requirement.txt. Here you need to change 220 to 201. And funny bit is that they have even mentioned in their repo that it works with 201, and yet they have mentioned this version in the Torch. So I have put it in 201 here. The rest you can leave as is. Let's go back to the terminal and then do pip install -r requirement.txt, and it is going to install all of those requirements on our local system. Again, this is going to take a minute, so let's wait. And that is done. Now, another change which I needed to make was this. Go back to this repo and then go to examples. In the example, I actually ran that Conformal LLM, and I had to change the code in 2 places. I will paste my code which I changed and I will show you what I changed quickly. So let me go at the top of this code. First thing I needed to do was to change the precision of the model. So from float 16 I changed it to float 32. This is what I did for the model, and the model is llama 2 7 billion, which is being used here as a test. And then another thing which I needed to do was this. So I just commented this line, and then I just added this. So I used torch.long data type here, and this is what I added. So these are the two changes I made in order to get this working. So now we know what happened there. Let's go back to our terminal, and then let's try to run this example. So I'm just going to minimize this if it allows me. Yep. Okay, that is done. Let's clear the screen and then run this. Now this is just an example how this thing works. You can modify the code and you can do your own testing. So we are testing the conformance of this LLM with the llama to 7 billion. So it is going to download the model first. It is yep, I believe it downloads the model first. Yes, so there are two shards of this llama to 7 billion, and interesting that they are using llama 2, which is quite old now, but anyway, still quite good, not bad at all. So it is downloading the model, and the code which I just showed you is just designed to test and evaluate the performance of conformal prediction method for LLM on a trivia question answering task. So it takes long time to run, but I will also show you a trimmed version with a sample output shortly. So let's wait for these models to get downloaded, and then we will see what happens. And the model is downloaded, as you can see here, and now it is going to work on that trivia question answering task for minutes, for maybe few hours. As you can see, there are a lot of them. So instead of this, I'm just going to show you a very trimmed down version of it. And now let me run it with the trimmed down version of the code. So I'm just going to run it again. It is going to load the model, and let's wait for it. The model is being loaded onto our GPU. I will also show you the VRAM consumption after this is done. So there you go. So it has given us error rate, average width, and coverage rate, which is basically related to this conformal prediction, as it is reporting metrics that are commonly used to evaluate the performance of these models. So error rate is the proportion of misclassified samples. In conformal prediction, the error rate is related to confidence level. A lower error rate indicates better performance. Average width refers to the average size of the prediction intervals. A smaller average width indicates more precise predictions. And then we have coverage rate, that measures the proportion of true values that fall within the prediction intervals. A higher coverage rate indicates better performance, but it may come at the cost of larger prediction intervals. So the error rate and coverage rate are related to the model's ability to provide accurate and reliable predictions, whereas average width of the prediction intervals indicates the model's precision. So by evaluating these matrices, we can gain a better understanding of our conformal prediction model strength and weaknesses, and that is what is happening here. Let me quickly show you the VRAM consumption if you are looking to run it by yourself. So it's okay, so it's not even running on CPU. I think it just flushed it. So maybe I will run it again, and then we will just check it out on our another window. So let's check it out. I think it flushed the LLM. Let's check it out. I'm just going to clear the screen here. I'll just keep it as is. I will run this code, and then while it loads, then we will check it out. Okay, so it is loading the shards, and now let's run it. No, I think it is all running on CPU. So that is a good news for you then. Okay, that's it. I think it's quite fast and quite good, which is amazing. Very nice. So that's it, guys. I hope that you enjoyed it. Let me know what do you think. If you like the content, please consider subscribing to the channel. If you are already subscribed, please share it among your network, as it helps a lot. Thank you for watching.